Hello everyone, hope you all are doing well. First things first, I'm very poor at English, so please bear with me for some time because today you are going to witness something new. That's for sure. It's kind of a disclaimer, but anyways. So today I'm gonna present a project related to ECE. Like our ECE engineers must be respected in every aspect, so this is basically for antenna engineers and IoT engineers to predict gain, efficiency and cost per area to set up an antenna. Now you might be thinking how this project is useful in real life applications. Now you might get a doubt that where we are using this in real life. Let's take an instance. Suppose you are a business enthusiast and you have a lot of money. Apparently you are a billionaire. Keep dreaming. Okay, anyways. So you wanted to set up a gigantic telecom venture in order to provide services to many of individuals out there around you. So to invest in such large venture, you need the knowledge and working of communication principles. Right? Without that you can't efficiently invest your money, because if you are thinking about to decide the height of antenna, there are many factors affecting it. Let's take gain, not gain, but let's take resonant frequency. Resonant frequency is indirectly dependent upon the height of antenna, right? If your antenna's height is not able to achieve impedance matching, now impedance matching is like a principle where inductive and capacitive reactances gets cancelled, and this is to minimize energy loss apparently. So if your antenna's height is not able to achieve that phenomenon, there would be maximum energy loss and your users can't access services as they would have thought. All the capital goes down the drain. Let's suppose you hired your friends as telecom operators, then it's an absolute disgrace for even for them. It might sound strange, but for an unemployed guy like me, that's the only option, right? Okay. Anyways, see, that shows the importance of parameters like bandwidth, accept ratio, gain, traffic capacity in running those big companies and setting up those big antennas and telecom towers. So that's the importance. Apart from this, antennas are also embedded in small chips, like we have seen that in Bluetooth modules like HC05. We have a small antenna, right? So this kind of project even gonna help for IoT engineers out there, as it reduces development time and helps them to optimize their design much more. So these are the areas that I personally feel that this kind of model could be implemented and utilized. Now, in order to train our model and deploy it on web application, so there are few steps to follow. So coming to the first one, it's obviously pre-processing and cleaning the given dataset. So let me write it down. And cleaning the dataset. This can be done using Python code by encoding, one-hot encoding, label encoding. So there is so much stuff like that. So now after pre-processing the data, our next step is to train our model. So I personally felt that here an algorithm named random forest algorithm would be apt, because you can train it anyway, there's no restrictions like that. But I personally feel that RF algo is better when we have large datasets and multiple outputs to predict, because even you can implement small like polynomial regression, but it won't be efficient. By visualization you would know these things slowly. So training a model using random forest thumb. So after that our job is to save this model somewhere, right? In order to deploy it on web, we need to save it in a file. Here we use a Python library called joblib. It stores this trained language model in a file with an extension called .pkl. The .pkl stands for pickle files, Python pickle files. See, main advantage of .pkl files is that it utilizes less disk space as compared to .csv files. So it's quite efficient. So let me write it down. Using joblib to save our model so that we can deploy it on web. Then last step is to deploy it on our web application using various kinds of methods, like you can even use Django, Flask, various kinds of backends, but I am familiar with Munstack right now. Here I am using Express to create my server and APIs, and I am using pgadmin in order to maintain my database, so that we can store all these predictions and inputs of users. We can store in that database and basically retrieve them back whenever they need, because they would get an idea to improve their inputs based on that data. So using Munstack deploy. Okay, these are the 4 major steps. Now let's start training our model. But before training model, we would like to once go through our data set and match those dependencies, because in order to separate the data set into independent and dependent variables, we need to have an idea about like how are these things dependent upon each other. Suppose I told you that resonant frequency is dependent upon height, but in what way and what kind? We need to go through these all parameters once, then we will try to train our model. Let's analyze our data set now. After seeing this, you might have your head spinning. I can understand that, but you need to have patience, right? Hold your horses a bit. We'll slowly know everything. I can understand how demotivated a person could feel after seeing stuff like this, and you have many more to go, like large quotes and all. Now most important thing at this time is to just have patience. That's it. That's only the option. Okay, anyways, let's get back to our topic. So here you can see in our dataset we are having various columns. So these are all antenna parameters which decide the working of an antenna or a radiator. Okay, if you observe these 3 columns, first 3, these are physical parameters like length, width and height. You might have a thought, how are these influencing how are these 3 influencing gain, efficiency and other factors? Okay, let's see how. Let me switch to notebook. Okay, first we'll discuss about gain. What is it? Gain of an antenna. Now okay, now in electronics we define gain as G equals to P out, I mean output power. So don't bother about my handwriting, it's very bad actually. Okay, gain is defined as output power by input power. Now this is unitless because both power units would be getting cancelled. Now if you want it in decibels per isotropic antenna, then you can simply write it as G equals to 10 log. Okay, 10 log same thing, power output by power input. Now this dBi is decibels relative to isotropic radiator. Now we will discuss this about later because all this is not required for now. Okay, now P out is output power and P input is simply input power that you give it to an antenna. Now you can see that gain is power dependent, right? It's depending on power more or less. Now how we define power of an antenna? Chalo, let's suppose you take a linear one. For our simplicity we are considering a linear antenna. So in a linear antenna, power is directly proportional to length square and inversely proportional to wavelength square. This is basic one. I think you might be knowing if you are studying electronics. Now this is the length of antenna. Now power is depending upon length of antenna and this gain is dependent upon power. So you can conclude that gain is dependent upon this length of antenna or height indirectly, right? So that was the point I want to mention it. So because you need to know all these things to decide whether which columns to keep in independent variables and which ones to consider in dependent variables. Okay, because when we are dividing our data set, you need this, right? So let me erase this all once. Okay, so that's it. Once again I am writing it properly. Gain formula of 10 log let's consider P2, like output power P2 by P1. Okay, this is a formula for gain. Okay, let's move on to the next parameter. After these three we are having epsilon r. Now what's this epsilon r? This is nothing but relative permittivity and it's a materialistic property. Now in physics you might have studied about relative permittivity while studying charges. So that is the concept here. It again influences impedance and resonant frequency. Now impedance frequency is nothing but a kind of resistance and resonance frequency we will discuss it here. Now resonant frequency is basically a frequency value. If you plot a graph between frequency and impedance, at some point both inductive impedance and capacitive impedance would cancel out each other to yield only purely resistive impedance. Wait, let me draw this once. So I am considering a plot between frequency and impedance. Okay, x-axis I am giving it frequency and this impedance. Okay, now the plot is going to look like this somewhat. And now if you consider this minima point, now this is signifying capacitive impedance. This curve, basically this curve is representing inductive impedance. Okay, if you consider this point, This is what you call it as resonant frequency. Yeah, I will consider it as FR. Okay. Now this is the point where you are only having resistive component. Now why do you require this resistive component? Why do you need it to be purely resistive? Because what's the problem with inductive and capacitive impedances? So this is basically for minimal energy loss. Okay, because lesser the energy loss, your users will benefit more. Users in the sense receivers end. Okay, so that's the concept here. Let's move on now. Coming to operating frequency, it's in gigahertz. Okay, the units are in gigahertz. Now it's just the frequency at which you operate the antenna. Now I'm not going much deeper into it. Now antenna type, it's just the type of antenna based on physical structure, frequency range, etc. So here also no need to go much deeper here. Accept ratio, and it's just the ratio of length to width. Okay, if length of antenna is some 5, consider. If width is 2, just consider. Then 2.5 is the accept ratio. That is the point here. Now coming to volume, again it's a 3D space occupied by antenna. Now you can give a volume of an antenna by L into B, width into height. So that is just for calculation and understanding purpose. Now we will discuss about this both later, feed ratio and electrical length. Now let's move on to S11 dB. Now S11 dB is in decibels, the units are in decibels. It's also just a measure to tell how much of input power is reflected back for an antenna, from an antenna. Suppose if you give certain force to an object, then it would return some kind of force towards you. Okay, now this is the analogy that you need to remember. Now coming to bandwidth. Bandwidth is a range of frequencies where you can operate your antenna. Now it's a range. You are having a lower cutoff frequency and higher cutoff frequency. Now let's see this ones. Okay, bandwidth. Basically in electronics, bandwidth is given by formula 2 into FR to 1 by 1 minus SWR. Okay, now SWR is standing wave ratio, that it's not required for now. Okay, now this is for lower cutoff frequency. Okay, lower one. For higher cutoff frequency, it would be simply 2 into FR 1 plus 1 by standing wave ratio again. Okay, this is the formula for bandwidth. Now here you can see that we are having only one value, right? We are getting two lower cutoff and upper cutoff values, but in this data set what we are considering is absolute bandwidth value. Now this is simply just modulus of higher cutoff minus lower cutoff, that's it. Okay, yeah. Now this is absolute bandwidth value. Okay, wait 1 second. Okay, now this is the bandwidth value. Yeah, now let's move on to the next parameter. Yeah, traffic capacity. Now it is just throughput supported by an antenna, because in electronics it's given by a theorem named Shannon-Hartley theorem. Now if you are going deep into that, it's required, but for now we are training a model, so we don't require that much understanding about it. But let's once see this Shannon-Hartley theorem, just a formula for it, because you have an idea, right? Now this channel capacity or traffic capacity is given by bandwidth into the log of 1 plus SNR ratio. Okay, SNR ratio is signal to noise ratio basically. Now this is a bandwidth value and this is signal to noise ratio, and this is channel capacity or traffic capacity, I would say, in bits per second. Okay, now in this data set we are considering traffic capacity as megabits per second. Okay, now that's what you should know. Coming to last three parameters, like you would see this gain, efficiency and cost. I think majority of you are familiar with it, right? Because being ECE students, it's necessary to have a grip about these three, because you are using it frequently in calculating various calculations. So we already had a discussion about them, gain, efficiency, etc. Okay, wait, there's again a catch here. Initially, now it's time to decide which variables you would take as independent columns and dependent columns. Now let me come to that. Initially I felt that this traffic capacity would fall under output parameter, since it's measured in bits per second, because probably an engineer needs an output on working of an antenna. So I thought that it would be better to keep it inside the output, dependent columns. But I eventually tried that way, but there was a problem. My model was showing some abnormalities, in the sense there was a huge gap between predicted values and actual outputs. So later I decided to retrieve back to the independent columns variable. See, this understanding of all this you were good at deciding independent and dependent variables based on that particular data set. Okay, this you will get it with practice and observation. You can even use ChatGPT, because nowadays all are using it. Anyways, it could replace jobs basically. Okay, okay, as we are done with this, let's move on to train our dataset with Python code. This would be interesting now. Okay, as we are done with the parameters, now we will proceed with training our model. Before training, we will process the data in the given set. Now let me open this antenna dataset with various parameters. Now you could see we have parameters like length, width, these are physical parameters, and all others like traffic capacity, gain, efficiency, etc. So by observation we can see that the column antenna type, if you observe this column straight away, you could see that the data in this is categorized. We have only certain types of antennas like microstrip, inverted F and planar inverted. Now while training the data, it is necessary to eliminate those dummy variables. Now you can do it either way. You can even use simple imputer, or else you can eliminate these dummy variables. So in this code I am gonna eliminate those dummy variables. Okay, now coming to our Python code. So let me open it in our Jupyter notebook. So this is our Python code used to train the model. So you could see firstly I imported all those required modules and libraries that we need to train our model. So once we'll go through this all, make sure that all these are already installed on your local system, because without installation you can't use them, that's obvious. So pandas is basically for reading and manipulating the data inside the .csv file. So it is used to organize your data in a better frame, making it accessible. So joblib, as I said earlier, it's used to save our model inside your disk so that we could deploy it on our web. Then matplotlib is for visualization, data visualization, and train test please is to basically divide our dataset into training and test sets. So coming to multi-output regressor, this one is the most important one. It enables training separate regressor for multiple target variables, basically, because here we are having more than one target. Like we are having 3 target variables: gain, efficiency and cost. So you need multi-output regressor in order to train separate regressors for these multiple targets, right? So random forest regressor is, again, it's one of the regressions out there. And R2 score is nothing but it's used to evaluate how the model's prediction match the actual values. Basically it determines how our model is well trained. So it's just for interpretation, like you can use it. Coming to this line is for loading all the data set within .csv file into this variable df. So if you execute this one, then after that I will execute one more line here, basically not here, wait. Okay, my bad. Okay, now I try to read what's inside this df, so it will provide all the data set for us. So this is the use of .read_csv function inside the pandas library. So then we need to separate both variables, I mean all the data set, into separately, like both independent and dependent variables. Variables in the sense here we mean columns for feeding our model. So in X I am basically storing all other parameters except these 3 parameters, because df.drop, what it does is it eliminates these 3 target variables: gain, efficiency percentage and cost, and it stores everything except these 3 inside X. Okay, and in Y I am storing again these 3: efficiency, gain and cost, because these are dependent ones, right? Okay, now if I try to read both of them simultaneously, oh no. Okay, now if I try to read X, I'm getting again all the independent variables. In X we are storing independent vars, and in Y we are storing dependent vars. You can see that. So moving on to our next step is to split our data into both training and test sets. Now here X-train and Y-train are both in which the model is trained, whereas we will use this X test in order to compare the predicted values with Y_test, because Y test is having actual values. Okay, for training our model we are just using X-train and Y-train. We have nothing to do with these both test sets. Okay, we will keep it aside. First, our main aim is to train our model using this X-train and Y-train. Okay, now I am just importing this function. So here test size equal to 0.2, it indicates that we are passing a 20% of the data into this test set, and the remaining 80% is automatically taken by training ones. Okay, that's it. Now it's time to train our model, right? We will train the model by just using fit method. After running this lines, our model is ready. Okay, it's showing some error, X-train is not defined because I forgot to run this line. Okay, this happens with me many times, but still I won't realize I do some mistake here. So it's better to rectify your mistakes. Don't repeat those mistakes again and again. Okay, like me. See, again it's showing some error. Life of a developer is like, you need to face always some errors. Like if you are facing these errors, then just start from the top, keep executing all those lines, just keep pressing shift enter. I think I might have missed some lines. Okay, yeah, I did miss some lines. Okay, that's fine. Now as our model is trained, you can see that we have random forest regressor here. This is our model which is trained based upon these X train and Y train values. Okay, still we didn't go with X test, please remember that. Wait, now here's the catch. At some point you might have thought like, can I encode or impute the data after splitting it into both sets? Oh come on, after all it's a human brain, so you might get these type of thoughts. You can probably give it a go. Wait, but it's always not recommended to do so. The reason is to avoid data leakage. Yeah, it's obvious. Because if you are already splitted those data sets and then you are imputing or encoding them, so you are already leaking that test data to that model, right? You are already leaking the test data. So for better results, it's always recommended to hide those test results. I mean test set. So hiding in the sets, completely isolating it from the training set. So this is a thing we shall keep in mind always while training a model. Okay, now this line of code is just saving our model with the name antenna underscore predictor .pkl. Now .pkl is Python pickle files. I already told you. It will store our model inside the disk so that we can access it later for deploying it on web applications. Okay. Heading towards web deployment, I am using Express for hosting APIs and Node.js for backend. So I have imported all my folders related to it inside Visual Studio Code. You can use any other code editor also, but I prefer VS Code because of its simplicity. So we have 3 files, you could see 3 folders. One is front end, Python model and backend. So coming to front end, I am storing all that front end stuff in this, all those HTML files and this styling sheets and all the images related to that, and obviously script.js, that is JavaScript logic. So this is about front end. So in back end, I am storing all server files and node modules. Okay, now in this Python model we have previously trained model. Okay, this is the file for that, and predict.py is just integrating our backend with this model. Okay, when we pass our inputs, this predict.py takes them and forwards it to our model. Then model predicts those values and returns it back to this predict.py. Then this predict.py will uh, give those JSON files to this server, so that this could be displayed on our front end. Okay, now coming to this intro.html, this is just an introduction one to brief about our application, so we can preview it once. Okay, wait, I am previewing it. Show preview. So this is the design that it looks like, so you can improve it. This is, I just added a glass morph and a beautiful antenna image in the background, so you can see it. Now, this is basic user interface. You can obviously customize it, there's no restrictions. Okay, remove it. Okay, now predict.html. In predict.html we just have all those parameters where we can give inputs and send them to our backend. So you can also see this ones. Okay, that's opening. Yeah, this is the page. Basically it looks like this. We can input different parameters and send it to our model trained in order to predict and display our values. Okay, you will see the displayed values here. Okay, let's move on now. Now register and login.html. This, it's a registration page again, where we can register, where a user can register themselves. They can create an account and keep track of their previous data, so that they can do comparison and improve their input feedbacks. Okay, now coming to this style CSS again. It's a cascade style sheet. We just added a glass morph kind of thing and an image to look it beautiful. Okay, looks cool. You can do it in your own way. Now coming to our backend, here comes the real challenge for you. We are using node package managers like Express.js. Wait, let me show you. We are using node package managers like Express.js, body parser, etc. Now this PG is for PG admin. Now PG admin again is a software that could, just maintain a database. Okay, here I am using PostgreSQL database. So this one is for that, and we are making various HTTP requests also, like app.use, app.post, app.get. So these are various HTTP requests like post, get, routes. Now this is all full stack development. We won't go deeper into it for now. Okay, it's time to run our server. In order to do so, just open the terminal from this view panel. Terminal, you can use Ctrl plus tilde also, that's a shortcut. So you have many options here like PowerShell, command prompt, git bash. So for now I am using git bash because I am familiar with those commands and I use it regularly. So in order to do so, just go into the backend folder by pressing by entering a Unix command line called cd. Okay, this again, I am very bad at spellings and English, so yes. Now this shows that we are inside the backend folder. Okay, because the server which I am going to run is inside this backend folder, so I need to direct into that folder in order to run this. Okay, just enter node mon server.js. Now what it does is, NodeMon is another node package manager which immediately runs the server after saving the changes in server.js. If you just use node server.js, then you need to run it again after saving those changes. So it just saves our time and our efforts. So better to use NodeMon. Just install it by using npm I space NodeMon. So you can do that. That is again part of full stack. So for now we won't bother about those things. Okay. Now in order to go to our server, now here you can see there's a local host. This is link. So I can control and click that to direct to my web page. Okay. So you could see that this is my web application basically, which runs on localhost. Okay. I still didn't deploy it on web. You can use tools like Heroku, or you can even use GitHub, right? But for now I am running it on my local space. Okay, now you could see this, welcome to antenna predictor. This application uses, I wrote some information about it here. So explore smart predictions, track your history, and this is a glass muff, and backside you could see some, I inserted an image to look it more appealing. Okay, now I go and get started. Now if I press some random values, it would give me a warning saying invalid credentials. So first, if you don't have account, then you can register for it. So I'm typing something like Kapil, it's my name, and password I could keep some random ones, 2 3 4 5 6. Okay, I'm pressing this register button. Now you are successfully registered. If you direct back to this login page, then it means your registration is completed successfully. Okay, now if you log into that previous credentials, yes, now you could see this page, predict.html page. Now I am entering some already saved values, random values. So I want to just check my model. You can select planar, this one, volume something, some value, length, bandwidth, traffic capacity. Then if you press predict, okay, I didn't, now it will take some time because your information need to come from that .pkl file, and it has to travel long. Okay, it seems to be working, I guess. Let's wait. Because the output to the backend would be given in .json file. Okay, see, you could see those results now. My efficiency percentage is 62.86. It's somewhat bad, but gain is 5.75 and cost I am getting per meter square is 208 rupees. Okay, now these are the insights which we already seen this in while training the model. So you could see here I am able to track my history. Okay, now these are all the values. Okay, see, these 3 columns I am also creating, I am also mentioning that at which time did you create that, so that again you could leverage it further. Okay, now this is all about our web application. So this is our project, but we are not done yet. Okay, we can even add more add-ons to make our application more beautiful and usable. Firstly, making this user interface more beautiful, because that's what is important nowadays to make a better looking site or better looking landing page, I would say. Then we can even use Flutter and deploy it on a Play Store also for Android users. So those are all secondary things. This is just a basic prototype to demonstrate these parameters, but you can do this anyway. So yeah, that's it for today. You can even think of more amazing stuff to make it you ready for industry usage. Going good, right? Lastly, I would again say please forgive if there are any mistakes in my vocabulary or video quality, or any mistakes there in code or writing something, because it's a basic prototype. I'm also here to learn. I was experimenting just with new things. So, as a human, I'm expressing my thoughts, okay? If I went anywhere wrong, please forgive me, because I'm also a learner, okay? Yeah, thanks for joining me. So we will meet again in some other video. Until then, keep coding.